Welcome back, viewers. In today's video, we are going to see what are containers. So, if you are in touch with the our channel, then you will know that in last 4 or 5 videos we had done the installation of containers in Blend OS. So, we had installed Arch and Fedora Rawhide as a container, and then we installed some apps inside the containers. So, you might be wondering what are containers. So containers are packages of software that contain all the necessary elements to run in any environment. In this way, containers virtualize the operating system and run anywhere from a private data center to a public cloud or even on a developer's personal laptop. From Gmail to YouTube to search, everything at Google runs in containers. Containerization allows our development teams to move fast, deploy software efficiently, and operate at an unprecedented scale. We learned a lot about running containerized workloads, and we have shared this knowledge with the community along the way, from the early days of contributing C groups to the Linux kernel to taking designs from our internal tools and open sourcing them as a Kubernetes project. So Kubernetes is a container project. So we will maybe in the future we will do a video series on Kubernetes. But right now we are trying to learn what are containers in short. So I have opened up this web page from the Google Cloud, and it has information about the containers in very short and sweet way, so you can easily grasp what is a container. So a definition of containers can be built. Uh, that is, containers are lightweight packages of your application code together with the dependencies such as specific versions of programming language, runtimes, libraries required to run your software services. Containers make it easy to share CPU, memory, storage, network resources at the operating systems level and offer a logical packing mechanism in which the applications can be abstracted from the environment in which they actually run. Now, what are the benefits of containers? So, first benefit is the separation of responsibility. So, containerization provides a clear separation of responsibility, such as developers focus on application logic and dependencies, while IT operations teams can focus on deployment and management instead of the application details such as specific software versions and configurations. So what happens is that this application team will focus only on the application part. So what are the versions of applications, their dependencies, how the applications are run, are they running properly, are they facing any difficulties? Then you have to give solutions to those difficulties and make the application run smoothly. While the IT operations teams can focus on the underlying system on which the container is running and the physical hardware. So there is a clear differentiation of the responsibilities. So both teams can focus best on their part of the responsibilities, and together they make the project a success. Now, second benefit of containers is workload portability. Containers can virtually run anywhere, greatly easing the deployment and development on Linux, Mac, Windows operating systems, on virtual machines or on physical servers or on a developer machine or in data centers, on premises, and of course in the public cloud. So they can containers can run anywhere. They can run on different platforms such as Linux, Windows, Mac. They can run on virtual machines, on our physical servers. They can run inside your machine, that is your laptop or desktop, or in data centers within the premises of your organization, and they can even run on the public cloud also. Now the third advantage of containers is that containers virtualize CPU, memory, storage and network resources at the operating system level, providing developers with a view of OS logically isolated from the applications. So now I will try to explain you this. Suppose you have running a certain application inside a container. Now the developer of that application can focus on that application behavior, how the application is running, uh, and how the dependencies are performing together with the application on an operating system level. So he can see the interactions between the application and the operating system below it, and he can see it in we can say isolation. So other applications, other processes will not interfere with his view. So only the application in question and the dependencies running for that application to work will be only the center of focus, and hence the developer can easily spot the bugs, he can easily squash the bugs, and he can easily make the system perform better. So in short, he can the developer will work less and achieve more. Now, what is the difference between containers and virtual machines? So most of the people are nowadays familiar with virtual machine. It is a guest operating system such as Linux or Windows running on top of host operating system with access to the underlying hardware. Containers are often compared to virtual machines. Like virtual machines, container allow you to package your application together with libraries and other dependencies, providing isolated environments for running your software services. As you can see below, however, the similarities end here as containers offer far more lightweight unit for the developers and IT operations teams to work with, carrying a myriad of benefits. So there is, it has got a long list of benefits. Containers are much more lightweight than virtual machines. Container virtualize at the OS level, while virtual machines virtualize at the hardware level. Containers share the OS kernel and use fraction of the memory virtual machines require. So what happens is that when you install a virtual machine, it will virtualize at the hardware level. It will use the hardware resources while it will also contain its own kernel. So if you have got 5 virtual machines running on your hardware, and those all the 5 virtual machines will have their own kernel. While if you run 5 containers, the containers will run with only the applications that are installed on them along with the dependencies. So they don't have that much code to run, and they don't contain the kernel also. They will use the underlying kernel. So suppose if you are running say 5 containers on the blend OS arch base, then all the containers will use the arch kernel. They will not have their own kernel. So this way it will save a lot of code that is being run parallelly, and it will save the hardware resources, and it will speed up your system. It will speed up individual containers also, as well as the base system will also speed up. And uh, and where these containers are used for, well, the containers offer a logical packaging mechanism in which the applications can be extracted from the environment in which they actually run. This decoupling allows container-based applications to be deployed easily and consistently, regardless of where the target environment is, a private data center, public cloud, or even a developer's personal laptop. So I will now offer you some examples. For example, I am a developer, I am developing certain application. Then to develop the application, what I will do, I will write the code and then I will test the code. So I will test the code inside a container, and that container will work on a target operating system. Say I will test my code on say Arch kernel and Arch OS. So the base system will be Arch kernel or Arch OS, and my container will run on the top of this, and applications installed in the kernel. Those applications will be tested by me, and since they are in isolation, I can easily identify the problems, the bugs associated inside the application. So what happens is the system logs will be also of a shorter length. Say if I got 1800 processes running on my Arch operating system, that is my host, then I cannot easily separate out the specific system logs, the application logs. But when I run the specific application in a container, the system logs and the application logs will be of a shorter size, and I can easily check out and spot the errors, spot the bugs inside the application, and I can easily work on it to remove those bugs and errors. This is one way. Second way is security. So say I am running some SAP applications inside a container. They are mission critical. They are very much important for the organization, and they contain some secret organization data. So I will use them in a container. So what happens is rest of the other applications that are say connected with the outside world will not come in contact with the this critical application running inside a container which contains the organization's critical data. So there is no chance of leaking the organization's critical data because that specific application containing this critical data is inside a container, while all other applications which can be accessed from the outside of the organization is running separately outside the container. So you can see my data is safe. So this is one way of isolation and the inherent benefits of having isolation to safeguard your data. So containers help you in agile development. So containers allow your developers to move much quickly by avoiding concerns about dependencies and environments. Efficient operations. Containers are lightweight and allow you to use just the computing resources you need. This allows you to run your applications efficiently. Run anywhere. Containers are able to run virtually anywhere. Wherever you want to run your software, you can use containers. So this is it, I think. Uh, Kubernetes, Google Kubernetes is another topic. It is more advanced. So we try to just first grasp all the basics. So we are now grasping the basics of containers. We have seen the two containers, that was the Arch container and the Fedora Rawhide container that we installed on the Blend OS, and we installed some applications also. We So in short, we have seen the containers how they work. Was presented to you to show you exactly in short what the container is, what are the advantages of containers, where the containers can be used. So in the next video, we will install some more containers, and then we will study how to manage those containers from the terminal. So see you in the next video. Bye bye.